So we currently have large language models, which are brilliant, I think, but they have some flaws. Of course, the number one flaw is that they do not have persistent memory, which means that anytime you run one of these things, it's essentially reanimating itself. It dies and then comes back to life. So the refresh rate of it is terrible, and you have to feed it in a bunch of data. Next thing is that these LLMs use a lot of resources. You need a really good graphics card or CPU to run them, and a lot of RAM and such. Now, I propose the idea of what I call a small tactile model, because it's the opposite of a large model, right? It's a very small model. Ideally, this should be able to run on if we can really get it going, it should be able to run on a microcontroller, so in the hundreds of megahertz. With a GPU as well, I mean a CPU, GPU combined microcontroller. Here we go. So this is a human head, for example. There's the eye, it's a sideway, and we can see that the LLM is the cerebrum here, the top. I hope I got that wrong. I hope I got that right. The top of the brain, which handles like thought, logic, imagination, creativity, all these kinds of stuff. To an extent, I guess there are motor skills. Essentially, what I was going for is the idea of the cerebellum, which is kind of like the subconscious, I guess. Though really, probably a better example would be to have the LLM as the head and the small tactile model as the body. So what this model does, it is for robotics. And it would be made up of partially machine learning and partially software, because a lot of this stuff you could do just in raw software, but you would want to train this model, so it would be trained with tactile data. Essentially, imagine 3D games. You need to train this model so that it understands physical collision, and you would first train it in three-dimensional games, like 3D game software, and then you would train it in real life, because it needs to have real life training. You don't want it stepping on like someone's pet or stepping on like a bunch of newspapers and falling or whatever, right? It needs to understand weight, needs to understand types of materials. So if it stands on a sheet of plastic, that's like strung in the air, it's going to fall through it, right, because it's heavy. While if it stands on a sheet of like metal woven fabric, it'll be fine, right? It needs to understand geometry. So all of these things are in video games, and we can replicate these, and that's how you can train them. It will, of course, need sensors. Now, this is where robotics really falls, because a lot of robotics is done with the visual sense.
So I just want to add that the reason why a lot of these robots are visual based, I believe probably, is that they're using these head capturing cameras to capture people doing like manual labor works and their jobs and like just domestic tasks and all that kind of stuff. So they're probably feeding that into machine learning model, and that's why it's purely visual based. But a purely visual based robot's just not going to work properly. Maybe if you mix it up with some other stuff, that might be all right. And another thing I want to say is that these tactile models would be really good at platforming video games, or video games that don't require text, essentially, that are purely based on moving, jumping, and like shooting, just like throwing a ball or something, right? So you would start off with 2D games, and it should be able to learn how to move in a two-dimensional world, and then 3D, and it should be able to dodge, just say like a spaceship shooting game. It should be able to dodge all the bullets and also use its own bullets to shoot, because it should be a master essentially of the tactile world, which all of these games are.
Which is the worst thing to do for tactile models. Tactile-based robotics. The visual is just one sense, but it's a very small sense in that you need to have actual tactile sensors, which essentially is a velocity velocity, if I correct.
Excuse my bad explanation. It is actually a rate of change of an object's position.
So if you understand x, y, z coordinates, which is essentially, it's x and y is your left and right and up and down, right, and the z is maybe it's the wrong, I forget. It brings in like that third dimension, so the forward and backwards, right? So it needs to be able to understand 3 dimensions, and you do this through velocity sensors, which basically will calculate position, height. So position and height technically is basically the same thing. Position is that, x, y, z positioning, and then the gyroscope is rotational based. So it's like up, down. If something is like slanted or whatever, it tracks that. Really, you could do a lot of this through just feeding its own data, as in like it's moving its limb, feeding it back to it, so it can have essentially you need a 3D virtualization. So it needs to virtualize the environment, which is what it uses its visual, so this is what the visuals get in here. But also you could use, there's new technology where they are using Wi-Fi routers, so essentially radio frequency, to be able to three-dimensionally virtualize a location in space. I believe, and correct me if I'm wrong, I'm pretty sure that is a thing. So you could use these for more advanced models. It would basically have it's psychic, right? It can just see through walls. It can feel the whole region, but otherwise visual sensors is fine. But inside of itself, it is building a 3-dimensional polygonal map. It's basically building like a video game reality of all the basic areas of like the geometry. If anyone's played maybe like the old Final Fantasy games, or like a PlayStation 1 game when they had those backgrounds that were like 2D, but you could run around in them. Basically, they had like crude 3D geometry in there, so that and acted as like walls or whatever, right? And its own body would be 3-dimensionally virtualized, and you could feed it its movement data, and it would understand again rotation and position, which are the main 2 things of its body and such. You would be able to virtualize this, but you do need again some kind of velocity or some kind of movement or some kind of sensors in it, which I believe there are some, right? There's probably plenty of these kinds of things. You do need these things, because otherwise, if it's purely running off software, it could just say, for example, someone could grab its arm and it thinks it's moving, but it's not moving, or it's like locked up against, I don't know, it's like caught under a table, the robot is, and it thinks it's moving, but it's not actually moving. So then it needs its 3D virtualization needs to be tested by sensors, right? So it's always feeling itself where it is. This way, it does not need to look, because it has its, just say there's like a table and there's a teacup on the table. It looks at this and it's like, okay, this is the crude virtualization, and now it looks upwards, and now it's looking here, and it can still use its little hand to grab the teacup, because it knows the XYZ coordinates of everything, right? And of course, this would be simplified geometry, and depending on the hardware, it would be better. Now, you would want to aim for at least about, this is pretty basic, I think, but at least 10 hertz, which is 10 frames a second of movement data. You could do less. I think you could start off with about 3 frames of movement data. I mean, look, you could even start off with 1 frame if it's if it's that bad, right? But 10 frames is probably a good. That's 100 milliseconds, or 10 times a second. It would be understanding itself, and you would only have to like reposition the world. See, everything would probably be at a different hertz rate, just to save on processing. And then more advanced models, you could have them all synced together. right? But otherwise it could build this little 3D world, and then you can refresh it every like so often, or whenever it detects something's changed, or if it places its hand there and the teacup's gone, it could then remove the teacup, or have like I don't know, a phantom teacup. Now it doesn't know where it is. Now the LLM and the small tactile model would communicate back and forth. The LLM is slow, of course, but it would feed the tactile model data to say, like, let's walk out the door. Let's walk out the door could take 10 seconds, right? So an LLM can keep up with that. A small tactile model, in those 10 seconds of the LLM, thinking, okay, let's go, basically it's a brain thinking, let's go to the door and open it, right? Simple command, go to door and open it. The small tactile model is generating the 3D map of the house, of the world essentially, and itself, and it's processing its limbs. It doesn't have to be humanoid, it could be animal-like, it could be whatever. This could be used in a factory, it doesn't really matter what it is, right? It's processing positional, locational, positional, rotational data, and whatever else we need, and it's processing again collisions, weight, materials, geometry, etc., depending on different hertz rates, because again we have to work with the processing power we want, and we want this to stay fairly simple. It will have to probably be done on GPUs as well. I do love CPU software rendering, but to be honest, it's a lot of different again, keeping all these 3D things, but I do think we could use less powerful GPUs. So again, you got to think like 3D graphics was in the 90s. We had 3D graphics. If you can, and then we had pretty decent 3D graphics around 2000s. We really only need 2000 era level 3D graphics. As long as this is stable and proper. So basically this model is processing all of this stuff at again 10 hertz refresh rate, or for weaker models 5 hertz, or 3 hertz, or even 1 hertz. And then once it has opened the door, gone to the door and opened it, it will send a message back to the LLM saying, I have opened the door, and I am here. What do I do now? Give me a new instruction. So there's this constant feedback loop between these two. And the small sensory model, which mostly it is just meant to handle all of this stuff, but it will actually no. So okay, so the LLM is looking over all the sensory data. It's working with all the sensory data, but because this small sensory model is kind of like a LLM, it'll probably have to understand like basic language, I assume, to an extent. Well, there's got to be some kind of way that these two can communicate back and forth, some kind of communication protocol essentially, which will be quick data, because you want a quick communication between them, but it will have to understand things like table, or box, or door, or person, or car, just so it understands again collision, materials, weights, geometries, entities. I should probably add entities. But yeah, really my idea is the LLM and the small sensory model and small tactile model are working back and forth constantly. The LLM is slower, but the sensory model is quicker, and it's constantly processing. Maybe we can think that the LLM is processing one hertz per 10 hertz of the sensory model. Maybe it's even like less than that. It's like it takes a couple seconds or whatever, but eventually we're going to have, we already have, NVIDIA just released that super powered Spark chip, which could easily run something like this. It could run both of these together. So we're going to have these like GPU, CPU chips. But even now, you could probably run these sensory models on like a 10-year-old graphics card. This is what I think. So anyway, what do you think? Do you think it'll work? I think it's pretty easy, to be honest. This is basically, it's the same thing as like video game AIs and such. This is how an AI works, right? They need to understand these things. It's just taking it to more complicated, and also using machine learning, because machine learning is an interesting little black box that produces these like crazy effects, right? And then if we have them communicating together, again, the idea of having specialized AIs that communicate and process different things instead, LLMs are a special AI for language, like logic, language, math, words. It's almost like the just like the mind aspect of it, and the persistent memory. The persistent memory, once we get that, is basically like almost like the soul, right? That's when we increase the hertz rate and we make it so that the LLMs can have memory, right? Can remember things without destroying themselves. But that's the whole other video. So I'll just leave you with that for now.